Imagine leaving Earth behind, crossing the orbit of the Moon, and heading straight out into deep space. You accelerate across millions of kilometers, flying past the rusted craters of Mars. You blow past the colossal gravitational pull and swirling atmospheric bands of Jupiter. You push further outward, leaving Saturn and its massive ring system in your rearview mirror. Finally, you reach Neptune. At 4.5 billion kilometers out, you have passed the last major planet. Travel even further, and you hit a broad ring of frozen debris. This is the Kuiper Belt, the icy domain of Pluto. For a long time, people assumed this dense ring marked the absolute end of the line. Yet, despite traveling billions of kilometers to reach this point, you are nowhere near the actual edge of our cosmic home. Keep traveling into the dark. Out here, the sun loses its warmth. It shrinks down to just another bright star in an entirely black sky. As you pull back, you realize the flat, organized disk of the planets is surrounded by an enormous, three-dimensional shell. It is a vast swarm of frozen bodies, stretching tens of thousands of times farther out than Earth. This is the Oort Cloud, the true, staggering frontier of the solar system. We have never seen this region directly, not with our most powerful telescopes and not with our deep space probes. If this massive shell is entirely invisible, how do astronomers know it is actually out there? The evidence periodically visits us in the form of long-period comets. Occasionally, a massive chunk of ancient ice will plummet into our inner solar system and light up the night sky as it nears the sun. By calculating the mathematics of these extreme paths, you can trace a comet's elongated orbit perfectly backward to a massive hidden reservoir far beyond the planets. Mapped on top of each other, thousands of these returning paths form a distinct spherical boundary. Every incoming comet acts as a physical tracking beacon, confirming the shape and location of an outer shell we cannot see. To understand how so much material ended up drifting out in the absolute dark, we have to look backward in time, about 4.6 billion years. The early solar system was a chaotic, crowded place. A rotating disk of gas and dust was actively collapsing and forming into new planetary bodies, resulting in constant gravitational tugs of war. As you can see in this model, Jupiter's massive gravity acted like a giant slingshot. When smaller, forming icy bodies drifted too close, the giant planet violently deflected their trajectories, flinging them outward with incredible force. The objects we detect in the Oort Cloud today are original building blocks of our neighborhood. They were born close to the sun, only to be banished to the absolute fringes by planetary gravity. Out on those absolute fringes, temperatures plunge near absolute zero, and solar radiation is almost non-existent. Back on Earth, rock and water are constantly reshaped by volcanoes, erosion, and life. But in the deep freeze of the outer cloud, there is zero geological activity or heat to cause physical change. These objects remain locked as perfect mixtures of water ice, methane, ammonia, and ancient organic compounds. Because they have sat undisturbed for billions of years, this enormous debris field serves as a pristine, frozen archive, holding the untouched blueprints of our cosmic origins. It is completely impossible for us to fly out and study this archive directly. Voyager 1 is the farthest and fastest outward-bound spacecraft humanity has ever launched, but even after decades of travel at tens of kilometers per second, it hasn't even approached the Oort Cloud's inner edge. At conventional speeds, a probe would need tens of thousands of years to cross the enormous gap to reach the cloud. By the time it arrived, human civilization could be unrecognizable. For the foreseeable future, this frontier is a place we can only explore through mathematics, deduction, and the comets that fall inward to visit us. All of this forces us to reconsider the scale of our neighborhood. Where does the solar system actually end? This diagram outlines two distinct boundaries. The small inner circle is the heliosphere, the physical bubble created by the outward flow of solar wind. But the massively larger outer circle maps the extreme limit of the sun's gravitational influence. That outer limit is exactly where the Oort cloud sits, acting as the final, distant anchor of the Sun's pull. The 8 planets we know so well are merely a tiny, bright island situated at the dead center of a vast, mostly invisible gravitational architecture. The edge of our home is not a neat wall in space or a single planet. It is a massive, silent, and frozen wilderness waiting out in the dark.